Hey guys, Mr. Ritz here, and I'm going to help you out with the first day of the 2.3 guided notes. So 2.3 in calculus is a very big section. We're going to learn two, probably the most important shortcuts that we will go over, and those two are the product rule and the quotient rule. Today what we're going to do is just look at the product rule. So that's all we're focusing on, and we'll get through it. So here we go with the product rule. We've learned that the derivative of the sum of two functions, meaning if we add the two functions together, it's just simply the sum of their derivatives. The rules for the derivatives of product and quotient rule are not as simple. So if we're adding two individual functions, we just take the derivative of this one and add the derivative of that one. Now, if they are being multiplied together, if we have two functions multiplied together, it doesn't work out. We don't take the derivative of this one times the derivative of that one. It'd be nice if it did, but it just doesn't work out. So the product of two differentiable functions, f and g, is itself differentiable, meaning we can take the derivative of it. Moreover, the derivative of f times g is the first function times the derivative of the second, plus the second function times the derivative of the first. So if we have the derivative of f of g, f of x times g of x, it is f of x times g prime plus g of x plus f prime. Now I will admit that I'm just stuck in the ways of my math teacher. I've also learned this one where it's f prime of x, g of x plus f of x, g prime of x, meaning we take the derivative of the first part, we leave the second part alone. Then we leave the first part alone, take the derivative of the second part. So we can use the product rule in a lot of different ways to help us out now. So if we have a couple of these derivatives here, like this one first, we could have, maybe let's do this off to the side. We could have FOILed this out and figured out, okay, this would have been 15x plus 12x squared minus 10x squared minus 8x cubed. And this answer would be, let's see, 15x plus 2x squared minus 8x cubed. So if we take the derivative of this, we should get 15 plus 4x minus 24x squared. All right. All I did was FOIL this out and use the regular product rules. Our regular just power rules, not product rules. Both start with P. I'm getting them confused. All right, what we're going to do though is let's do the product rule here since we have this expression times this one. So what we would do if we want to find h prime of x, the first derivative, we're going to take the derivative of the first term. Our derivative of 3x is 3 minus derivative of 2x squared is 4x. And we're going to leave the 5 plus 4x alone. Then what we're going to do is take the derivative of, or leave the first part alone, 3x minus 2x squared, and take the derivative of the second part. The derivative of the second part, well, derivative of 5 goes away, derivative of 4x is just 4. So we get this expression here, and if we were to FOIL this out, let's see, we'd have 3 times 5 is 15. We'd have a plus 12x. Then we'd have a minus 20x and a minus 16x squared. And then over here, we'd have to distribute the 4. We'd get a plus 12x and a minus 8x squared. And if we simplify this, we'd have a 15. How many x's we got? We got 12 minus 20 plus 12. So it'd be 24 minus 20, that'd be 4. And then we'd have a minus 16 and a minus 8, that makes a minus 24x squared, which is the exact same thing that we got here. So this problem here is probably not like the best example of why the product rule is important, but it shows or proves that the product rule works. Now the reason why it's important is that when we have problems that we can't just FOIL out and simplify. So if we have like x squared times sine of x, we can't distribute this at all. It's just x squared times sine of x. But we should be able to still take the derivative of that function. So the derivative of x squared times sine x, we take the derivative of the first part, which is 2x. We'll leave the sine x alone. And then we'll leave the x squared alone, and we'll take the derivative of sine x, cosine x. We see if we can combine any of those together. We really can't. I guess the only thing we could do is factor out an x, but there's really no points. And that's the derivative. So this equation will tell us the slope at any point of that one. All right. So let's keep this going. We'll do some more practice problems here. A lot of practice to get us used to this. All right. So we got a couple more here. All right. So we got 4x times e to the x. Okay, so let's take the derivative of the first part. 4x, the derivative of that is 4. We'll leave the e to the x alone. Then what we want to do is leave the 4x alone, take the derivative of e to the x. And this is something we haven't learned. So maybe make a note off to the side that if f of x equals e to the x, the derivative of e to the x is e to the x. E to the x is an extremely special function where it's derivative of itself. So the derivative of e to the x is e to the x. It's the only function out there that is like that. So the derivative of e to the x is e to the x. The only thing we could do here is, I guess we could factor out a 4e to the x, because both of these have a 4, both of them have an e to the x, and we would have just one left over here and x. And there's your answer. Okay. Now, typically where we see this is with trig functions. So if we have cosine x times sine of x. All right, well, let's take the derivative of the first part. The derivative of cosine of x is a negative sine of x. We'll leave the sine of x alone. Plus, now we'll leave the cosine of x alone. We'll take the derivative of sine of x, which is cosine of x. So what we get here, we can simplify this because sine of x times sine of x is sine squared. So we'd get negative sine squared of x. And then cosine of x times cosine is cosine squared of x. And there's our answer here. We probably could look at some trig identities to see what this is equivalent to. The only trig identity I would hope you know is that sine of x plus cosine of x is 1. But since this is negative, it doesn't work out that way. Okay. Well, actually, let's use that kind of thought process to help us figure out this one. What's sine squared of x? Well, before we take the derivative, it'd probably be better to change this to sine of x times sine of x. And so when we take the derivative, all right, we'll take the derivative of sine of x, which is cosine. We'll leave the sine of x alone. Then we will leave the sine of x alone. Take the derivative of sine, which is cosine of x. Now these two things are the exact same expression, cosine x, sine x, cosine x, and we can add them together. So we would have two of them, 2 cosine x, sine x. Okay, so there's a brief breakdown of the product rule. Now we can apply the product rule to other things. Remember, we can always use the derivative to find the slope at any point. So if we have x times sine of x, and we have a point on there at pi over 4, let's find what the derivative is. Actually, that should say what's f prime of x. So, and then what is f prime of c? What's the point, the value of the slope plugged in at that point? So first thing we got to do is find the derivative. We'll take the derivative of x, which is 1. We'll leave the sine of x alone. I plus, now we'll leave the x alone, and we'll take the derivative of sine of x, which is cosine of x. So there's the derivative. That's pretty much all we can do when it comes down to trig functions. What we want to do next is to find the value at the slope at that point. So we want to find f prime of pi over 4, meaning we're going to take our derivative equation. We're just going to change all of our x's to pi over 4. Okay, so look at our unit circle here. What is sine of pi over 4? Pi over 4, the sine of it is radical 2 over 2. Now this pi over 4 is being multiplied by cosine. The cosine of pi over 4 is also radical 2 over 2. So the answer would be radical 2 over 2 plus pi radical 2 over 8. There we go. Now that would have some decimal approximation there. And if you want to plug that into a calculator, you can always do that. All right, one more thing to show you guys with the product rule. Now the product rule is not limited to just 2 functions multiplied together. It's also can be the derivative of multiple functions multiplied together. So if we have f of x times g of x times h of x, that would be f prime of x, g of x, h of x, f of x plus f of x, g prime of x, h of x, plus f of x, g of x, h prime. So if we look to see what happens is we take the derivative of the first, we leave the rest alone. Then we take the derivative of the middle one, we leave the other two alone. And then we take the derivative of the last, we leave the other two alone. And since we're multiplying here and adding, as long as we do each one, we'll be fine, and we'll just combine what we can. So if we have the derivative of x squared times sine of x times cosine x, what in G golly could that be? So we have x, sine of x, and cosine of x. So let's take the derivative of x squared, which is 2x, and we'll leave the sine of x alone, and we'll leave the cosine of x alone. Next, we'll leave the x squared alone. We'll take the derivative of sine of x, which is cosine of x, and we'll leave the other cosine of x alone. And then next, we will leave the x squared alone, and we'll leave the sine of x alone, and we'll take the derivative of cosine, which is negative sine of x. So the only thing we really can do here, we can't simplify this out. It's just 2x sine of x, cosine of x. All x squared times sine of x is, or becomes, is x squared cosine squared of x. And x squared times, that becomes just a negative x squared sine squared of x. There we go. So we get this really long expression here. That's what we use to find the slope, but well, we're just practicing, we're doing all the training we can to make sure we understand the product rule. So what you guys need to do today is the CYUA worksheet. So remember with these worksheets, guys, you can turn them in anytime you want. If you don't turn them in the next day or you don't take a picture, you will be marked, it will be marked missing, but you guys should be all right with that. So CYUA, we're just looking at the product rule. I will see you guys next time for the quotient rule. Have a good day.